In this video, we'll look at unions of sets. Referring back to our list of campaign promises, suppose a pollster wants to summarize the types of promises made by the candidates. The pollster would need to study all promises made by either candidate, or the set MTSPC. The set is the union of the sets of promises as shown in the Venn diagram below. The shaded part is the set under consideration. So here we have the M, which was in both sets, the TS, which was in candidate one's promises, and the PC in candidate two's promises. Algebraically, we write that the set of MTS union with the set MPC is MTSPC, the set MTSPC. The symbol, well, this large U, the union symbol, which is sometimes called the cup, which goes along with the cap of the intersection symbol. The cup you fill up with everything, the cap you put over the specific things you want. So the symbol union represents set unions. The union of sets A and B, written A union B, is the set of all elements belonging to either A or B. A union B is equal to the set of X such that X is a member of A or X is a member of B. Form the union of sets A and B by first taking all elements of set A and then also including every element of set B that is not already listed. Do note that if you include elements that are already listed, that is not incorrect because we do not consider elements in a set twice. Example, finding unions. We're going to find the unions of each of these sets. So our first set, the first union we're looking for is the union of the set 2, 4, 6 and the set 4, 6, 8, 10, 12. So we're going to have a 2, 4, and 6 in both of these. We've got a 2 in this certainly, and a 4 and 6 because those are all in set 1, the first of the two sets. And then we look at the second set. Well, we already have a 4 and 6, so we don't have to duplicate those, but then we also have 8, 10, 12. And there is the union. In this second one, in B, we've got the union of the set A, B, D, F, G, H with the set C, F, G, H, K. So we first take every element in the first set, A, B, I'm going to leave some space, D, F, G, H, leave a little more space, because when we come over to this one, we have elements F, G, and H from the previous set, but we also have C and K. Finally, we're going to look at the union of the set that contains 3, 4, and 5 with the empty set. And the answer to this is that the union of these sets is the set that contains 3, 4, and 5. Nothing is added when we take the union of our first set and the empty set because the empty set contains no elements. Recall from the previous section that A prime represents the complement of set A. Set A is formed by taking every element of the universal set U that is not in A. As an example, we'll find intersections and unions of some complements. So we're going to let U be the set that contains 1, 2, 3, 4, 5, 6, and 9, while A is the second that contains 1, 2, 3, and 4. B is the set that contains 2, 4, and 6, and C is the set that contains 1, 3, 6, and 4. So we're going to find each of the following sets. We're going to start with A prime intersect B. Well, first we need to take A prime. A prime is going to be the set that does not contain 1, 2, 3, and 4, but contains everything else. So that's the set that contains 5, 6, and 9. And we're going to take the intersection of that with B, which is the set that contains 2, 4, and 6. So since we're taking the intersection, the only element that is in both of these sets is 6. So this is the set that contains only 6. Next, we look at the complement, the union of B prime and C. So B prime is the set that does not contain 2, 4, and 6, but contains everything else. So that's going to be 1, 3, 5, and 9. And we're going to take the union of that with C, which contains 1, 3, 6, and 4. Oh, sorry, 1, 3, 6, and 9. So both of these sets contain 1, 3, and 9, but one contains 5 and the other contains 6. So the set is the set that contains 1, 3, 5, 6, and 9. Now we take A, the intersection of A with the union of B and C prime. So we'll start with A, which is 1, 2, 3, 4. And we're going to take the intersection of that with, and we're going to put this in parentheses, B, which is 2, 4, 6. And the complement of C. C is 1, 3, 6, 4. So this is everything that is not 1, 3, 6, or 9. So that is going to be 2, 4, 5, 2, 3, 4, and 5. No, not 3. Yeah, 2, 4, and 5. There we go. Okay, so now we take our A, 1, 2, 3, 4, and we're intersecting that with the complement, with this union, which is going to be the set of 2, 4, 5, and 6. So we're taking the intersection of these two unions. So we find every element that's in both of them. That's just going to be 2 and 4. So this is the set of 2 and 4. Finally, we're taking the complement of the intersection of B and C. So that's going to be the intersection of 2, 4, 6 and 1, 3, 6, 9. Well, the only thing that's in that set, and we're going to take the complement of that, the only thing that is in both of these, the only thing that's in the intersection is 6. So that's going to be the complement of the set that contains only 6, which is everything that's in the universal set that isn't 6. So we wind up with a set that contains 1, 2, 3, 4, 5, and 9. Okay. Finally, we're going to describe some sets in words. We want to figure out how we can describe each of these sets in words. So first, we're looking at A intersect B union C prime. Okay, so this is going to be the intersection of A with the union of B and the complement of C. Second, we have the intersection of the union of A prime and C prime with B prime. So we want to say that this is going to be the intersection of the union of the complements of A and B, of A and C, with the complement of B. At this point in time, we don't really know what these sets will look like, but we don't need to right now. We'll get to that later.